Professor Peter Gregory here for Business 4300 Data Analytics. For this assignment that's coming up here, I want to give a little guidance on net present value. Some of us might or may not have had finance yet, so NPV is your net present value. Most often it has to do with inflation. Okay, so we want to know how the erosion of the dollar, if we're in the United States, the whole idea here is if we settle on some kind of inflow, if we don't account for inflation, as the payments go on out in time, they become worth less and less. If we have basically the same amount of money coming in, it's a standard cash flow coming in, then over time, period by period, it's worth less and less because of inflation working against us. The other way to look at it is a matter of interest on some kind of money that we either lent or borrowed. Or finally, the third thing has to do with opportunity cost. Okay, so this is the one that probably you're not as familiar applying. Okay, and this has to do if we have a project A and we have a project B to work on. A has been around for a while. We might have history, 10 years or 20 years or 30 years. Think of the car industry trying to decide to go from a baseline model A to some major conversion over to a B. And over 10 years, we know what the rate of return is on this project. Should we undertake B, considering risks and other expenses that it takes to convert over, switching costs and things like that? Okay, so we can take a look at what we get as an annual return or periodic return on project A, and then we can discount B to see whether this comes out above water compared to the project A. That's a whole idea of opportunity cost. Which one is worth more? Okay. So if we imagine we have some kind of financial statement here, it could be cash flow or P&L, your profit loss or cash flow statement, and we're going to mark this into row headings here. These are going to be categories of either expenses or revenue. Cost of goods sold. And we'd also like to know what we call rest of world expenses, which would be all the other overhead items that might be applied that we obviously spend money on, but don't go directly into the product itself. So rest of world, ROW. Okay, and then revenues is equal to sales. Okay, and as a quick reminder, we might have expenses which go toward running the company, and then we might have expenditures, which is any outflow of money. And why they're different is expenses would fit as a subcategory underneath expenditures. Expenditures could include investment. If you happen to have some cash on hand, you're going to put it away into investments until you need it for some future event. And one of the things that happens with Apple is they're making so much money, it's hard for them to make more money. So they're sitting on a lot of hard cold cash. And then investors have to wonder, basically you're investing in Apple, who might have money just sitting in accounts in other kinds of investments. So you're really indirectly investing in other things. Just something to think about beyond the types of problems that we're going to have here in Business 4300 for Chapter 2. Okay, so this is referring to Chapter 2, Problem 6 for the homework. So we'll have some categories in here as far as your expenses go, or our expenses go. We have revenues in here, right? And then basically profit is equal to revenues minus, that should be a minus, expenses, right? Revenue minus expenses. That's all we have. Usually in our table, we'll have a double line, usually indicates we're doing some kind of total here. Okay. So the outflows, the negatives, are at top, positives at the bottom. Okay. So we'll take a look at our periodic. Okay. So this is going to be period 1, period 2, period 3, period 4. Okay. And what we might do is, I'm not going to go through the upper part of this, but we're going to have subtotals down here, so that for period 1, let's say we have an annuity type of thing that always rolls in as $1,000 a month or period. Now remember, the period could be a year, could be a month, could be a quarter. Pretty much those are the most common ones. Month, in fact, for most businesses is the most common one. So for our period, and a period, there's going to be a discount rate associated with it. Let's call it 8%. Okay, so remember, what is 8%? 0.08. We've got to remember that number. Okay, and that's the discount rate over some time. Okay, so let's imagine that for periods here, that we're actually using years. So this could be, this period is a year 1, and this is a year 2, this is a year 3, and this is a year 4. Okay, just as well, this could be quarter of just 1 year. Okay, so this could be just all year 1, right? So period 1 is Q1, Q2, Q3, Q4, and we have to pay attention to how we're given the discount rate here. Okay, so in our case, we're going to keep it really simple and try to keep this as a relatively quick video for people that can kind of bump along on the lily pads here and get from A to Z without like a deep dive and then getting confused forest for the trees for what we're even talking about here. All right, so I'm going to use a very basic case here of 4 years. Period 1, 2, 3, 4. Each period is 1 year. Okay, so we're using the years up here. Okay, and let's say, for example, here that we do something that we said, okay, Mr. and Mrs. Customer. So what we say is, Mr. and Mrs. Customer, you owe us $4,000, and we're going to pace your payments out over 4 years. Well, what happens is, let's assume that our discount rate here, we're referring to the inflation. Okay, so let's say there's 8% annual inflation here. Okay, so what we need to do when we look at discount rate is we make some kind of assumption that the period we're measuring and the payments on it are at the end of the period. Okay, so I'm indicating end of the period. There are some cases when you will actually look at the beginning of the period rather, and you have to make some adjustments for that. But for the basic case here, usually you look at, you've put this money out there, they give you $1,000 after holding on to it for a year. Then this other $1,000 they've held on for 2 years, they pay you at the end of 2 years. This other $1,000 they've held on for 3 years, and the last $1,000 they've held on to 4 years. So the first year at the end of the year has gone under the effects of 1 period's worth of inflation, but the other 1,000 has been sitting under there for 2 periods, and a third has been sitting under 3 periods worth of inflation, and finally the fourth is under 4 periods of inflation. So this one is going to be discounted by 1 period's worth of inflation. This is going to be discounted by 2 periods. This is going to be discounted by 3, and this is going to be discounted by 4. Okay, so really quick, without getting into the equations here, I'm going to give you this because this is probably what you need to get going on problem 6, is how do we discount the first payment? It's $1,000 over 1 plus the period discount rate raised to the number of periods. So the first one is going to be raised to 1, right? Anything raised to 1, actually anything raised to 0 also, but anything raised to 1 is itself, okay? So for the first period, it's simply going to be 1,000 divided by 1.08. That's 1 plus the discount rate. We're just going to raise that to 1, okay? And then we're going to do a discount on the second cash flow, inbound cash flow, $1,000 over 1.08 raised to the 2, okay, because it's the second period, right? 1,000 over 1.08 to the third, and 1,000 over 1.08 to the fourth. Okay, I can't do that in my head, so I'm going to run over to Excel to do that. But you can see what we do is we take each payment, and it's incurred some kind of inflation period. In this case, we're using inflation over this period: first, second, third, and fourth. Okay, and I use the little caret symbol here. The reason I use that is we're going to go use that in Excel. I just want to kind of remind you that that's how we actually, the total is going to be equal to that, and what we use is this caret to raise something to a power that we're going to need over there in Excel. All right, so let's run over to Excel and put this in here really fast. Okay, so we'll say that this is, we'll call it year 1 to be clear. If I hit tab, it moves to the next cell to the right, year 2, and then I'll take advantage of Excel's copying capability. So we have year 1, 2, 3, and 4. Okay. So the payment is equal to 1,000. So in Excel, usually you want to set up a key like this to make full use of Excel. We're going to set up a key table here for the key numbers that we have in here, and the discount rate is going to be annually is going to be 8%. So I'm going to put this in here as 0.08, but then I'm going to format it as a percentage here We'll use 2 decimal places, and I'll say OK. So it shows us 8%. Okay, so year by year, we're going to say this is going to be equal to this payment up here divided by 1 plus this discount rate raised to what period are we in? We're in the first. So we'll just put that in there. Now, I encourage you to use all the parentheses necessary to keep the order of operation clear. I don't even trust it myself. The plus minus, divide, multiply, and the power functions in any mathematical equation, I don't trust the order in Excel. I don't trust myself with it. So I always put all the parentheses in there that I need to make sure that I've got the right orders of operations here, so that the divide here is going to be the last part of the formula that gets executed. So I hit enter. Okay. So what this says is $1,000 after one period's erosion at 8%. In today's dollar value, we're actually only getting 925 and 93 cents. We'll round that up to $926. Okay. So now, if we're careful with our formula, what I can do is go back in there, and I'm going to use absolute referencing by grabbing the cell that I want to lock down, and I'm going to hit it with F4. Okay, so when I hit F4 on this, it drops dollar signs in front of the column and the row, which makes it absolute referencing. And now I can grab that formula and just drag it across, and it won't auto increment the cell reference for the discount rate. And just to show you what you can do with F4, sometimes I'm going to hit it again. If I hit F4 again, it'll go through this cycle here. I'm going to show you that we go through a cycle here and getting the exact kind of referencing we want. So we went from totally relative, we started out with, we got totally absolute referencing, and now we're just absolutely referencing the row number. We have a dollar in front of the 2. That will not increase if we move to the right. It normally wouldn't anyway. Okay. And then if we hit it one more time, F4, it then changes it to absolute referencing the column and lets the row float, if you will. Okay. If I hit it one more time, it goes back to the beginning. And so it cycles through here. F4, you can get what you want. You can go around and around and around. I'm holding down the F4 or clicking the F4, and I can go around the cycle. And for the purposes of this discussion, I'm going to use both row and column absolute referencing. Okay, so I'm going to leave that like that. So I've just modified my formula so I can drag it across here. Okay, we're going to do one other thing here. I'm going to give myself one new row, and I'll show you how we do this in Excel. We're going to put down the number of the period here. Okay, is 1. It's trying to format that incorrectly, so I have to come back down here. Excel's out ahead of me here, and I just want a simple number, and I want it to be an integer. It's going to be what period we're in. I said OK, and then I'm going to type 1 back in there. So Excel tried to be smart and tried to copy the formula or copy the format of a cell above it to this one. That's why I had to just go through there and remove the formatting on it. Okay, so that's period 1, period 2. We're going to use these in the formula. Okay, so we have period 1, 2, 3, 4. I'm going to come back to my formula here, and instead of raising it to a hard code 1 where I actually type that back in there, I'm going to use the cell reference here. When I hit that, the number, our solution doesn't change here. And while we're at it, I'm going to turn it into accounting format because it's dollars. And yeah, we'll leave it as 2 pennies. We'll show the pennies there. Okay, it does the rounding for display purposes only. With a little bit of work, we now are able to just drag this across here. Let's see what went wrong here. Actually, we need to lock down that as well. So we'll hit that with an F4 and we'll turn that into absolute referencing. Okay, and now we'll drag that back across there. So we had to do that a couple of times. So what are we seeing here? We're seeing that after the second year, $1,000 that we got was eroded by 2 periods of inflation. And now, instead of us receiving $4,000, which we charged the customer, because we gave them terms that they can pay over 4 years, in today's dollars, they're only paying us $857. Okay, so we have to watch out for this when we do long-term contracts. We have to put a correction into the payment that involves inflation. it accounts for inflation in there. Otherwise, where we thought we were going to have $4,000, what do we really have? I'm going to come over here, hit Alt equals, which is a shortcut to do the sum. And instead of $4,000, we got eroded by something like $678, is it? Or $688? $688. All right. So that's how much erosion went on, which is a significant part of what we were after. Okay, so we could do a few things here. We can make this clean for ourselves. Generally, you want to go back, or as you go along, periodically start cleaning up everything and formatting it well. Okay, so this is the period that we have here. These are the periods. If you so care to type that in there, you can put the period, and I'll put in like period number so we know what period it is. And this is just going to be which year we're working with. I'm just putting in row headers here, and this is going to be the present value payments of each period. Okay, and so we already calculated NPV. We already calculated that, but I'll do it again. This is the NPV. Net means you add things up, so we added it all up. It came out to 3,312, and I'll just do this again. And what we're going to do is Alt equals, but we're going to have to work on this a little bit. Okay, and so I'm going to tell it which cells to add together. Those four. For what we did is we added that together. So we've figured out the net present value using primitives is the name that I use, or other people use, for actually we're using the primitive here. We use basic multiply, divide, raise something to a power within Excel, but there is an NPV formula here. So we'll put in NPV, a little F after it. We'll use the built-in formula for Excel. I'll give you a quick view of this. It's going to be very simplistic here because what we're looking at is what you might call like an annuity, where we're getting $1,000 every month over the next 4 years from there. It's one way of looking at it, and another type of financial instrument. And for our sake here is what we're going to do is we're going to use NPV. I'm going to show you the formula version of what we just did by primitive. We'll use the rate. If you look right here, it gives you all the hints that you really need. What's the rate? That'll end up being 8% or 0.08. And then it wants to know what the values are that we want to add together. Well, this is a pretty simplistic version of using NPV, so because all our payments are the same. So it's going to be C1, C1 again, C1 again, and C1 again. We have 4 payments of $1,000 at that rate. So every payment that we indicate here is interpreted by the NPV formula as the period payment going forward. Okay, so if we just hit enter on that, we end up with the same number. That always makes us very confident. But it is very valuable to go through and use primitives to make sure where you get in trouble in Excel is when you go out and start using formulas and you can't rebuild the same scenario using primitives. You might not have a good control over what NPV is. Once in a while, you'll hit a formula that's not working for you, and you have to back down and try to do things in primitive to get the right answer. And then that will actually help explain how the formula works. So that's it. That's for problem 6 of chapter 2 of Evans. Should give you everything you need to create a little base case that they give you there. And the NPV is the area in that you probably need a little bit of help with. But you can understand from here, I think you can take enough out of here to be able to get that problem done. Very good. We'll see you in class.